Today I'm going to talk about hemostasis. Hemostasis is the body's response to a cut, injury, or something that's going to make you basically bleed. Okay, some type of injury. Now hemostasis has three different types of stages. We have the vascular phase, the platelet phase, and the coagulation phase. All these phases add up to basically to form a blood clot in your body, in essence to stop you from bleeding. Okay, so now that we've introduced the three steps, we're going to first talk about the vascular phase. Now the vascular phase is a very important phase in hemostasis because it's the first phase that responds to injury. Basically what happens is you have tiny vessels. In those vessels you have smooth muscle. The smooth muscle in here, when it responds to a cut or a scrape, is going to constrict. It's basically going to prevent the blood flow that would usually go through these vessels to constrict, to prevent the loss of blood flow from that cut. Now this phase is known as the vascular spasm. Okay, the vascular spasm will then lead to a phase called the vascular phase, which basically, the vascular spasm, which is basically talking about constricting the blood vessel, only lasts for about 30 minutes, which then leads to the period of the vascular phase. Now in that vascular phase, you have certain things. You have endothelial cells, important things that are released. You have endothelians that act almost basically as a peptide hormone that stimulate that smooth muscle to basically contract, like I talked about, and basically to speed up the smooth muscle cells and the fibroblasts to accelerate the repair process inside that smooth muscle. Next, we're going to move from the vascular phase to the platelet phase. Now the platelet phase is pretty simple. What happens in the platelet phase, you have these little endothelial cells right here. They become sticky from this vascular phase. Okay, and what happens here is you start forming little platelets. Now these platelets are trying to have a little party. Okay, they are going to basically respond to this injury here in your smooth muscle, and they are going to form the platelet plug. They are going to attract more and more of these little platelets and say, hey, you know what, we are injured, come here and clot this up, please. Okay, so now we're going to start with our first process, which is going to be the extrinsic pathway. The extrinsic pathway starts with this tissue damage right here, okay, at the endothelial cells, okay. Now, from there, we're going to follow it up to the tissue factor, which is going to be the first process of the extrinsic pathway. Basically, the tissue damage is that damage to the endothelial cells or the peritoneal tissues, okay. Now, the greater this tissue damage, basically, the faster the clotting is going to occur. Okay, from there we're going to follow this up to the sodium ions that are going to basically form with the clotting factor, the Roman numeral 7, okay? Basically, what this is going to do is going to activate this enzyme, the tissue factor complex. In order for us to get to factor X, where we want to go to get to basically to get this blood clot to occur down here, we need to get to the tissue factor complex, and this is the series of steps that we take to get to the tissue factor complex in order to activate factor X. Okay, so now we're going to talk about the other way of forming to get to factor X, and we're going to start down here with the intrinsic pathway. Now the intrinsic pathway is pretty much similar to the extrinsic. There's a couple other factors that are different though. Here would be one. Instead of having where you would have tissue damage, you would have activated proenzyme, which is usually going to be factor 7, okay? Now factor 7 is activated from these endothelial damage, so the tissues that are damaged, okay? What's going to happen is it's going to come up here and grab onto the platelet factor, which is basically attracting more platelets to it, okay? And then it's going to also, once again, combine with sodium ions to form clotting factors, okay? Now clotting factors consists of factor 7 and factor 8, which then combines to activate the factor X activator complex, okay? Which basically is the same thing as the tissue factor complex. We need this in order to activate factor X. So we started down here and we activated certain steps in order to get to this factor X activator complex in order to activate factor X. Whether it be the intrinsic pathway now or the extrinsic, either one can form to activate factor X, which is going to be the common pathway. Now the common pathway starts by converting to prothrombinase, which is an enzyme that is pretty much going to activate prothrombin, which will then lead to thrombin, which will then break into fibrinogen, and from there will release a plasma protein known as fibrin, which will lead to your blood clot. This is the overall steps of hemostasis.